keep pencil like this and release it. Just change this length. So what will happen to pencil? How do it will, what type of motion it describes is what you have to make of it. Then come to the question. So if you don't have dining table or tables, or we don't have any table, we don't have any cot, so a platform, or go to the some window, you'll have a platform on the window, no? So there you keep pencil and keep it some length, this one. So he has given PC equal to rod AB of length L and PC equal to L by 3. If you keep pencil like this, nothing will happen. It will stay on the book. So this is called like a offset. This is called like a offset. Some length, it should be projected outside. Then it will tip, no? It will fall. So when it is falling, how actually it happens here? What actually happens here? There is a coefficient of friction between the rod and the corner, the edge. Because, so it will start tilting, no? Then there's a coefficient of friction between the corner and the rod. That is what mu. So how that mu and theta, they find the angle theta at which rod starts slipping at corner. So first what will happen? What will happen to rod? What type of motion the rod will describe? Will it slip, then tip, or will it tip, then slips? What do you mean by tip? Rotating that one. Will it swing about point P, then it will slip about point P? Or will it first slip, then it will swing? You should make observation. Now, why do it will swing? Why it should swing? So talk about point P. The weight of the rod will act through point C, no? So mg into the distance PC. So clockwise torque is acting. So it will swing here. So first, what will happen? Will it slip, then swings, or will it swings, then slips? This will not help you from physics. You must have a general idea. I think, shall I say, it will first swing, then slips, no? First it will swing. Then what will happen? As it starts swinging, then it will start slipping here. So general motion, so somewhere here. Yeah. I'll just give the diagram so that at least come for this. So this is the corner. I'll draw all the set of diagrams. Huh? So there's a rod. So the moment you release, the moment you release, so center of mass will be here. So what will happen to the rod? The rod, what will happen? The next position of the rod will be oh. I'll put some dotted line or else. And what is the next position of the rod? After this, the rod will start tilting. So what will be the point? I think the which point of the rod was in contact. So this let me take this is A. This A, B. The point D was in contact. So still point D only will be in contact. Still the point. So we'll agree this. So this what happens here. Or the point D will be somewhere here. Some other point will come. No. So in very next moment, so now at certain angle, what will happen? It starts slipping. As it starts slipping, what happen? Other point of the rod will come in contact with the point P. So our question is only this one. So what should be the value of mu so that it will start slipping? Start slipping means very next moment what happen? There's a threshold angle theta. Very next moment, so what happen? The rod will start slipping at point P. I think you know enough for friction concept. We have discussed the slipping idea. So for it will rotate for what angle theta? What is maximum angle theta for which no slipping occurs? That's what the question here is. If the calculated theta becomes more than this angle, then slipping starts occurring. So what is the maximum permitted theta? For that, find the angle theta at which rod starts slipping. Able to understand the question now? Okay, let's get into diagram. So now show the rod tilted. That you are supposed to fight. You have to fight with the problem. How to assume direction of friction? How to assume direction of friction? Tell me, equations will help. Equations will not help. No, the basic your observation skills from that only you're supposed to bring. No, there's a rod. No. Why it is not coming straight line? Okay, let's get into the problem. This was the end A, this is B, and center of mass, let me take it here. This is C, and this is the point P of the corner, this is D. What are the forces that are going to, and it will rotate about point P, shall I put? The rod will rotate about point P. The rod will rotate about point P, simplest idea. The rod rotates about point P. So therefore, the angular acceleration, what we have to show about point P only. So this is about the point P. Then it will have tangential acceleration. At, you write it. First, I'll show the forces. How the normal contact will act in this direction. Just write n. That will be sufficient. Now this angle, let it be theta. Let this angle be theta. We know distance PC. PC is given equal to L by 3. How to get the direction of friction? Everything we brought it. No? And in this position, what is the state of the rod? It will also have angular velocity. It will also have angular velocity. How to get the direction of friction? Yeah, whose help you have to take? Better take centrifugal force. You stand at point P. You stand at point P. Component of weight will act along AB like this. Then centrifugal force will also act along AB. Then we will balance that, the friction. So the friction should be upward. Agreed, all of you? Sir, why you brought centrifugal force? I can bring. What's wrong in that? You stand at point P. Or you are standing at the ground, then F minus mg, component of weight mg, this will be how much? This is theta. This is theta, mg cos theta. F minus mg cos theta will be required centripetal force if you stand on the ground. Okay, let's write all the equations now. So this is, I think, enough of equations we have brought it. And now how the tangential acceleration should be like this. A tangential, and how it should be perpendicular to the rod. This A tangential is what? Due to angular action. So shall I put rod rotates about point P. So therefore, what is A tangential? A tangential should be equal to L by 3 into alpha. There's the one equation what we have. Let's get into the problem. What all equations we have to write? First, we'll calculate omega. So earlier center of mass was here, no? The center of mass got descended. So how much center of mass got descended? By distance y. So decrease in potential of center of mass, mgy, should be is equal to moment of inertia of the rod about point P into this one. So this is a conservation of mechanical energy. What should be the y? Sine theta should be equal to y by pc. Pc is L by 3, so y will be L by 3 sine theta. What is the moment of inertia? ml square by 12 plus m L by 3 whole square. From where this equation I brought it? From where this equation? Parallaxis theorem, moment of inertia of the rod about axis passing through point P. How is the axis? Axis is passing through point P perpendicular to plane of paper. Parallaxis theorem, ml square by 12 plus m into L by 3, pc whole square. The parallax theorem. Solving this, I'll get the omega. So omega is equal to 3g sine theta by 12. So this is equation 1. Keep it equation 2. Then what about the motion of the rod? About point P rotating, no? Then who will provide centripetal force? I say, sir, I'll assume friction downward. I think it's very easier. Friction, if you assume downward, then F and what can be this? This is theta, and this is theta, no? This angle is theta. Who will provide centripetal force? If you assume friction downward, friction plus mg sine theta cannot provide centripetal force, no? If you take F downward, I think totally wrong. I think that will help you a lot. So therefore, F minus mg sine theta should be the required centripetal force because rotating about point P. So writing centripetal force. So this is the work energy theorem. I'll put some box like that so that it'll be easy for you. So this is based on what? Conservation of mechanical energy. Then let me apply the next for rotatory motion about point P. As the rod rotates about point P. I think I'll slide up till here. What is the equation? F minus mg sine theta. Why m omega square L by 3? Because what is the distance of the point C from P? L by 3. But it's a total rod rotating, not, it's a, sir, what is this equation? It's a body, no, not a particle. But how you can write L by 3? The whole mass, where it will appear to be constant at center of mass. So this is due to rotating motion. Due to circular motion, this one. So we know omega. Substituting that omega, I'll get one equation, 3mg sine theta by 2. So call this equation 3. This is 1. Okay, let's come for any other thing. Torque equation, we'll write it. We'll write torque equation. motion of this one. So first translative motion will discuss. So like along y-axis, mg minus, so sorry, this one, instead of this, perpendicular to the rod, mg cos theta minus n should be equal to mat. We know at, L by 3 alpha, substituting that, mg cos theta minus n equal to ml alpha by 3. So equation 4. So from this what happened? And so what is this alpha is there. So let's write the torque equation. So we'll calculate alpha. That alpha I'll substitute, I'll get the n. Then n and f I'll compare, we'll get the required condition. How to write the torque about point P? mg into net torque about point P, IP into alpha. Now what should be the torque? mg. I think all of you, I'll visible. Yeah, fine. I think total problem visible. Just make observation. mg into L by 3 cos theta should be equal to moment of inertia of this. Already we know. ml square by 2l, ml square by 3 into alpha. Solving this, we'll get alpha. That alpha, I'll substitute the equation 5. The value of alpha I'll substitute. Then we'll get expression for n. So I think I ended up with this. Put 5 in 4. N will become equal to 3mg cos theta by 4. Okay, you know f and you know n. For what should happen? First the rod should slip, or first it should rotate, then it will slip, no? So therefore, what is the value of mu? Mu should be equal to f by n. Solving this, I'll end up with answer 2 tan theta. Cross verify once. N you know, so this is equation 6. Solving equation 5, 3 and 6. So this will be our answer. So now you see the motion little bit, rotating motion, then torque we brought, circular motion, centripetal force. So first what happened, the rod will first rotate, then why do it slip? Any reason, sir? What makes it to slip? How to analyze this? Okay, fine. This is about mathematics. We got some answer. So so after what angle, after rotating through what angle, theta it will slip, will determine the mu and this one. So now, sir, any rigid body, will we get this equation? No. This is a rod. You take triangular plate, release it, we'll get some other situation. So different rigid bodies.
Why isn't there any centripetal force?
What happened?
Sir, why isn't there any centripetal force?
That only I wrote, no, here, centripetal force, m omega square L by 3.
Okay.
Yeah. Okay, fine. So now what's happening here? The rod will rotate. Okay, sir, it will rotate. Why after certain angle, after rotating to certain angle theta, why it should slip? Because see, there is some upper limit for f, no? Mu n. So as it starts rotating, as theta increases, omega will increase. So please, you have to bring your physics into a picture now. As the rod starts swinging, theta will increase, omega will increase. Then this omega will increase. Then after at certain specific angle theta, the centripetal force will not be sufficient to keep it in rotating motion. So therefore, what should happen now? So it will start slipping. This is the background. Because the omega will keep on increase here. Then the centripetal force will not be sufficient to keep the rod in circular motion. So therefore slipping occurs here. So you take rigid body, when you leave that surface rough, it must first slip. If there's smooth, sir, what will happen? Analyze this, what's wrong? If there's smooth surface, if surface is smooth, immediately it will start slipping, no? If the surface rough, first it will rotate, then it will slip. Getting the idea? This is, okay, now what we did for rod. Now, sir, what happens if it is a, other than rod, can we work out, or only for rod only such numericals we can solve? There's a generalization now. So the whole rigid body has to be learned like this only. First rod, then generalization. First for rod, then generalization. After some time, it will have both translate. See, once it slips, both translative and rotative will come into picture. There's the other part. But first only rotation. Then once it starts slipping, then both the motions will occur. No, let's see that. The very first thing, triangular plate, let's see that. So it will be very easy for you. Center of mass. So will come somewhere here that we have to find out. So I'll release it. So triangular plate also same situation arise as the same conditions you have to put it in. So mg will act, force mg will act. There's a point P, and it's a rough. The moment what happened now, the triangle, it will take orientation like this. Please do follow the method what I'm telling. First for rod, then for any other rigid body. If you do for rod, so that it will be easy for you to analyze all the concepts, everything. I think this was the diagram. So I'm trying my level best to not like this. Huh? Yeah. Yeah, fine. Now you say, let's say it's a center of mass is somewhere here. It need not be at same level or some arbitrary point, and this is theta, you take it. So again, the set of equations will be same. Continue, mg. Then how the normal contact? Normal contact will act here, perpendicular to this line. This is a normal contact. Then here about what point it will rotate about this point, alpha. Then it will also have angular velocity. Then all the friction again here. If you want to move the center of mass a little bit below down, so the friction must act here like this. Then work out the problem. Then component of weight will act here. Then centrifugal force, or you can say centripetal force, component of friction will provide centripetal force. At one position, maybe it can happen that component, the mg will be acting vertically and it not be this one. If this is exactly at the level of the horizontal one, means if center of mass is exactly at this level, then component of mg will not come. Then we will provide centripetal force only the friction. So the friction must act here like this only. So again, when center of mass somewhere here, check it. When center of mass comes below here, check it. At least unable to solve, at least draw the diagram and check it, how various forces are acting. So this is about the triangular plate slipping. Then semicircular plate you can bring. I think it's unlimited, no? The way of learning things is unlimited. So after some time it will tip. at least what happen, you must have a basic idea of the what will happen there. This is what happens. First it will rotate. So theta. So center of mass here it will be somewhere here. How the friction? The friction will act here. So now please at least draw a diagram. You'll be in a very comfortable position. Different shaped objects kept at corner and it will tilt. So first it should tilt, then it will slip. So nowhere situation will come where first it will slip, then tilt. No, first it will tilt, first it will rotate, then slipping will occur. Because as theta increases, omega will increase, then the friction will not be sufficient to keep that in circular motion. So there the slipping will occur. It will leave circular path, better to say about point P. And the normal contact. I'm just showing the basic things. Remaining all you are supposed to work out. This is the center of mass. Okay, it's a unlimited, no, the way of asking questions. Okay, now I brought one question. Read it. Time I think only 13 seconds, 13 minutes. We'll try. We'll see. Okay, we'll do one thing. Tomorrow I'll discuss that one because we have time. So let me finish off here. Reaction one. One more very important is there, so that this idea will completely get over. So this is the